Hi, today we'll be solving Physics 9702, Paper 2, Variant 2, February March 2017. Question 1. Complete figure 1.1 by putting a tick in the appropriate column to indicate whether the listed quantities are scalars or vectors. So, a scalar only has magnitude, while a vector has to have a direction, right? Acceleration is definitely a vector because you write it in plus and minus sign too. Force is also a vector, and kinetic energy is a scalar, momentum is a vector, quantity, power is scalar, and work also scalar. Make sure you memorize these because there's always a question on this. A floating sphere is attached by a cable to the bottom of a river as shown in figure 1.2. The sphere is in equilibrium with the cable at an angle of 75 degrees to the horizontal. Assume that the force on the sphere due to the water flow is in the horizontal direction. The radius of the sphere is 23 centimeter. The sphere is solid and made from a material of density this. Show that weight of the sphere is 41 Newton. So for finding out weight, you can first find out the mass, right? And for mass, you can use the formula density is equals to mass over volume. Since density is given, volume is also something that you can find out. You can take out the mass. So what is the density? It is 82, while volume is what? The radius is given, so you can do some calculations. You know the formula of volume, which is 4 over 3 pi r cubed. So 4 over 3 pi, make sure to convert 23 centimeter into meters, and that will become 23 divided by 100 to the power of 3. Calculating this would give you an answer of mass being 4.18 kilogram. Now using this, you can use the formula for weight is equals to mass into gravitational potential, sorry, not gravitational potential, only gravitational field strength. So 4.18 into 9.81 would give you an answer of 40.9, and that is approximate to 141 newtons. The tension in the cable is 290 newtons. Determine the upthrust acting on the sphere. You can refer back to the diagram for this question. Let's try to draw some forces out. So here, wait. For example, this is exactly in the center. I can't really draw it exactly in the center. Yes, so this is weight. For example, the tension is this black robe you see, and you obviously know that upthrust acts in opposite direction to weight, so let me draw it with another color. So the same exact weights arrow, there would be an upthrust. So we can see from the diagram that tension plus weight, tension plus weight gives upthrust because they are in the same direction, but the tension here is not this one. It's actually what? Let me go back and write it in the space. The tension is not the one the cable is showing. The tension is vertical component of tension plus weight would give us the upthrust, right? So let us find out the vertical component of tension. Let's try to draw this triangle here. So this is the cable, and you can see that this angle right here is 75, and we have to find the vertical component. So that would become what? We have the tension given to us, which is 290 newtons. We have to find out this part here, so that will become sine 75 into 290. So vertical component 290 sine 75 plus weight was also found out in the last part, and that is 41, and after calculation you'll get the answer as 320. This would give you 321 newtons. Explain the origin of the upthrust acting on the sphere. The origination of upthrust is always due to difference in pressure on top and bottom of an object. So you can write the pressure on lower surface of a sphere is greater than the pressure on upper surface of sphere. State the principle of conservation of momentum. Sum of momentum of bodies before is equal to sum of momentum of bodies after. Make sure you memorize it. It is a very simple definition. Two blocks A and B are on a horizontal frictionless surface. The blocks are joined together by a spring as shown in figure 2.1. Block A has mass 4 grams and block B has mass 6 grams. The variation of the tension F with the extension X of the spring is shown in figure 2.2. So here's the graph of force and extension. Okay, so the first part is the two blocks are held apart so that the spring has an extension of 8 centimeters. Show that the elastic potential energy of spring at an extension of 8 is 0.48. Elastic potential energy is always the area under force extension graph. So at 8 centimeters, the force is 10 point, no sorry, it's 12. Simply you take the formula of triangle, which is half a plus b into height. So half, actually this is not the formula for a triangle, this is for trapezium. Triangle's formula is just breadth into height. So 12 into 8 over 100, since you have to convert centimeters into meters, and the answer would be 0.48 joules shown. The blocks are released from rest at the same instant. When the extension of the spring becomes 0, block A has a speed of this and block B has a speed of this. Fine, for the instant when the extension of the spring becomes 0, use the conservation of momentum to show that. Okay, so you have to find out the ratio between kinetic energies of block A and block B. Okay, so for this question, this sentence right here is a very big hint. You can use the conservation of momentum principle to first write out an equation. So for block A, equals to block B. So the mass for block A is 4 and the mass for block B is 6. Okay, so 4 VA and 6 VB. So this is the equation we found out. And now we can just find out the ratio for the velocities. VA over VB would give us 6 over 4. So here we have done this. Now we need to find this. We need to show this. So kinetic energy formula is half mv square. So the ratio would become what? 0.5 into the mass of block A, which is 4, and 0.5 into mass of block B, which is 6. And for velocities, you just need to put in the ratio that you found out here and square it. Doing this calculation would give you an answer of 1.5. Moving on. Use the information in B1 and B2.1 to determine the kinetic energy of block A. It may be assumed that the spring has negligible kinetic energy and that air resistance is negligible. Okay, so we have already in part 1 found out the elastic potential energy, and then we can use that 0.48 joules. We can construct an equation that whatever the elastic potential energy that was stored in the spring would be converted to kinetic energy of both the blocks. So elastic potential energy is equal to kinetic energy of block A plus kinetic energy of block B. But we cannot just use it as it is because this is also unknown. So we are going to convert this into, let me put it down. I can convert kinetic energy of B using the information here, which is plus KE of A over 1.5, because we shifted it here and shifted 1.5 here. And then doing the calculation, you're going to get, let me solve it here, 0.48, and this equation right here will give us the answer of 0.29 joules. The blocks are released at time 0. On figure 2.3, sketch a graph to show how the momentum of block A varies with time until the extension of the spring becomes 0. Numerical values of momentum and time are not required. Let's try to figure out what will be the gradient of a momentum time graph. So for this graph, we know this formula: force is equals to change in momentum over change in time. So from this we know that force is the gradient. At first, the block is something like this when the velocity here is 0, because we know that it is at rest initially, and after the block is moving very fast. So velocity here is something which is like really fast. So we know from this that our graph would be starting from the origin. So one point that we found out about our graph is that just a second. Is that it will be starting from the origin and endpoint. The starting point is here. The endpoint would be somewhere here, because momentum is very high because it is traveling at a greater speed later. So we found out 2 points. Now we need to find out how are we supposed to define the gradient of this graph. Is it a curve or a straight line? From this equation right here, we know that our force is our gradient, right? So in this situation is what is happening to the gradient, what is happening to the force. The force is very big because the extension is big, right? So the force is also big. While in the second situation, there's no extension, so the force would also be 0 because extension is 0. So in the first situation, the gradient, which is force, is very large, while in second situation, the gradient is almost 0. So from this, we know that the graph is going to be a curve. So let me draw it. Okay. It should touch the origin. And so there are some pointers that you need to take care for this graph that are mentioned in the marking scheme. So firstly, it should pass from origin. It should have decreasing gradient. And third thing is, in the end, gradient should become 0. This is the origin part, this is the uh, decreasing gradient part, and this is the gradient becoming 0 part. Define velocity. Velocity is the, let me change the color. Velocity is the rate of change of displacement. A car travels in a straight line up a slope as shown in figure 3.1. The car has mass and travels with a constant speed of 9.0 meter per second. The car's engine exerts a force on the car of 2000 Newton up the slope. A resistive force due to friction and air resistance opposes the motion of the car. The variation of the resistive force with the speed v of the car is shown in figure 3.1. So this is the resistive force and speed. State and explain whether the car is in equilibrium as it moves up the slope. The car is in dynamic equilibrium as it moves with constant velocity. So resultant force is 0. Consider the forces that act along the slope. Use data from figure 3.2 to determine the component of the weight of the car that acts down the slope. Let's first try to draw what they're asking. Or maybe I can just show on the diagram. Make sure to use the diagram very carefully. So this right here is what? It is the driving force. And we know the driving force is given as 2.0 k Newton. And friction is also acting. So we were given the graph. We can find out the resistive force when the speed is 9 meter per second. So let's read the value. At 9, the resistive force is 0.4 k Newton. So 0.4 k Newton. That is the resistive force. So there is also a component of weight, which is basically the mass, 850 into 9.81 Newton. Now what they're asking for is this. How can we find this out? Since this weight acting down the slope is in the same direction as resistive force, let's form an equation. Driving force is equals to resistive force plus weight down the slope. This equation is true because the equation is in equilibrium. So driving force is 2000 newtons, resistive force is 400 newtons. We are finding out the weight, and the answer would be 1600 Newton. You can write it as 1.6 into 10 to the power 3. Show that the power output of car is this. So power output, you can use the formula of power is equals to force, actually the driving force. Remember, this is not just any force, it is the driving force into velocity. Simply multiply the driving force, that is 2000 Newton, into the speed which was given, and the answer would be 18,000 watts. You can write it as 1.8 into 10 to the power 4 watt. The car now travels along horizontal ground. The output power of car is maintained at this. The variation of resistive force acting on car is given in figure 3.2. Calculate the acceleration of car when its speed is 15 meters per second. So let's go back to the graph. At 15 meters per second, the resistive force is here, and it's 0.65. Sorry, 66. So resistive force 0.66 k Newton. We have an idea that since we have to find out acceleration, this formula must come in use. So let's draw a diagram to help us out. The car is traveling on a horizontal ground. For example, this is the car, and what we only have is the output power, which is constant to 1.8 10 to the power 4, and we know the other thing, which is resistive force, as 0.66 k newtons. So from this, we also know the 15 meter per second speed, so we can use the formula of power is equals to force into velocity again. Power is the same, driving force, and velocity is 15, and the driving force will be 1200 Newton. Let's put it in our diagram. Okay, now we need acceleration. So first, in order to use this formula, we need resultant force, and resultant force can be found out by subtracting driving force from resistive force, and 660. The answer would be 540. Let me make some space. By 40 newtons, and now we can very easily find out the acceleration from the formula. Acceleration is equals to force over mass. Force is 540 over mass is 850, and the answer is 0.64 meter per second square. Moving on. State what is meant by the Doppler effect. So the Doppler effect is when observed frequency is different to source frequency when source moves relative to observer. A child sits on a rotating horizontal platform in a playground. The child moves with a constant speed along a circular path. An observer is standing a long distance from the child. During one particular revolution, the child, moving at speed this, starts blowing a whistle at point P and stops blowing it at point Q on circular path. The whistle emits sound of frequency this. The speed of sound is given. Determine the maximum frequency of the sound heard by the distant observer. So we know the formula. Frequency observer is equals to speed of sound over speed of sound, speed of source into source frequency. So for a maximum frequency of the sound heard by the observer, the denominator should be smaller, right? So we need to subtract. Okay, let's put in the values. Speed of the sound 330, speed of the sound minus speed of the source, which is 7.5, and the frequency of source 950, and the answer is 970 hertz. Describe the variation in frequency of the sound heard by the distant observer. Okay, so you can simply use the values for maximum frequency and minimum frequency. Maximum we found out was maximum frequency of observer was 970 hertz. Minimum is coming out to be, you are just going to add when finding out minimum, and that would be 930 hertz approximately. So just write down that frequency decreases from 970 hertz to 930 hertz. I'm going to skip this question because it is from electric fields chapter, which is not a part of AS level physics syllabus anymore. 3 resistors of resistances are connected as shown in figure 6.1. The total current in the combination of resistors is I and the potential differences across combination is V. Show that the total resistance R of the combination is given by the equation this. Okay, so you just need to derive it. Looking at the diagram, we know, let's just label it first. This right here is I1, this right here is I2, and this I3. Since they're connected in parallel, we can say that total current is equal to I1 plus I2 plus I3. And current is equal to voltage over resistance, and each of the resistances are given as R1, R2, and R3. So just plug them in. The voltage will remain same. As you know, in parallel circuits, the voltage doesn't change. So we're just going to write V. Now take V as common and write 1 over R1 plus 1 over R2 and plus 1 over R3. Wait. This is equals to I. Now shift this V and it becomes I over V is equals to 1 over R1 plus 1 over R2 and 1 over R3, and this would become, this right here would become what? 1 over R, since R is equals to V over I. And just write all the other as the same. There you go. And this is shown. A battery of electromotive force 6 volts and internal resistance R is connected to a resistor of resistance 12 and a variable resistor X. Okay, by considering energy, explain why the potential difference across battery terminals is less than the EMF of the battery. So they're basically asking you the potential difference between these points. So EMF is what? EMF is total energy available per unit charge, right? But here you see that there is an internal resistance, right? So there must be some work done to move the charge, and hence there must be some lost volts, right? So energy is dissipated in the internal resistance of the battery. A charge of 2.5 kilocoulomb passes through the battery. Calculate the total energy transformed by the battery. You can simply use the formula energy is equals to VIT we know that charge is equals to IT. So this is charge. So it would become 6 into 2.5 converted from into 1000 because there's a kilo, and it would become 15,000 joules. The number of electrons that pass through the battery. So it's very simple. You divide the charge, which is 2.5 into 100, 1000, divided by the charge on a single electron, which is 1.6 into 10 to the power minus 19, and the number would be 1.6 into 10 to the power 22. The combined resistance of the two resistors connected in parallel is this. Calculate the resistance X. So since they are in parallel, we know this equation, 1 over R, so this is combined resistance, would be given by 1 over the resistance of one resistor, which is 12, and the resistance of other resistor, which is X, and by calculation we will get the answer as 8. Use your answer in B3 to determine the ratio power dissipated in X upon power dissipated in 12 ohm resistor. Just use the formula power is equals to V square over R. So power dissipated in X would be given by V square over 8, and power dissipated in 12 ohm resistor would be V square over 12. This would be V square over 8 into 12 over V square. V square gets cancelled out, and this would be also cancelled out. 6, 3, 2. So the answer is 1.5. The resistance of X is now decreased. Explain why the power produced by the battery is increased. As the resistance of X is decreased, the total circuit resistance would also decrease, and by this equation, power is equals to V square over R. If resistance decreases, power increases, since power is inversely proportional to resistance. A nucleus of bismuth 212 decays by the emission of an alpha particle and gamma radiation. State the number of protons and the number of neutrons in the nucleus of this. Okay, so the number of protons is 83, and the number of neutrons is 21. 212 minus 83, which would be giving us 129. The gamma radiation emitted from the nucleus has a wavelength. Calculate the frequency of this radiation. Since the formula is speed is equals to f lambda, and where frequency can be found out from speed over lambda, we know that gamma radiation is a transverse wave, and we also know it is an electromagnetic spectrum, and all the electromagnetic waves have the same speed, which is of 3.0 into 10 to the power 8 over the wavelength, which is given 3.8 picometer. Pico is 10 to the power minus 12, so 3.8 to 10 to the power minus 12, and the answer would be 7.9 to 10 to the power 19. Explain how a single beam of alpha particles and gamma radiations may be separated into a beam of alpha particles and a beam of gamma radiation. Okay, you can simply use an electric field at an angle to the beam. Why? Because alpha will be deflected, while gamma radiation an alpha particle emitted from bismuth nucleus has an initial kinetic energy of this, and as the alpha particle moves to air, it causes the removal of electrons from atoms. The alpha particle loses energy and is stopped after removing this much electrons as it moves through the air. Okay, so this part of the question is also out of syllabus, so let's just skip this. So that's it for this paper. I'll see you in the next video.